Yes, Pradeep, we are live now. You can start. Thank you.
Okay, sure, sir. Thank you. I'm sharing my screen. Okay, right. You guys see my screen, right? Please confirm anyone.
Yes, we can see it.
Okay, nice. All right. So, yeah, this is my presentation. And good afternoon. Sorry, good evening, everyone. Welcome to the Guided Lab 4, which is auto healing and auto scaling on the in Kubernetes. So, right here, my name is Pradeep Nilaboyna. I'm from Group 2. I'm here to present the Guided Lab 4, auto healing and auto scaling. And here you see the Docker symbol. So what is Docker means? So it's basically it's a Docker, the technology which runs the containers. That's it, one line, simple. So today I have like two important topics, auto healing and auto scaling with HPA. HPA is a horizontal pod autoscaler in the auto scaling category. So right now, I'm starting with what is Kubernetes? So, sorry, what is container? So basically, our container looks like this. So we deploy our app in our container, and it has a core, runtime, and settings, and everything self-contained, portable, isolated. So which has all these six problems, and out of which I just highlighted like these two I'm going to fix today. No self-healing and no auto scaling for the what of the Nginx app, for example. And what is Kubernetes? So I have came up with a very realistic, simple example. Like let's consider a restaurant chain, and one rest like the restaurant cooks pizza, and it has only one oven, uh, and one container is running your app. So uh, when we consider like pizza, it's an app. So one app running one container, and it has like only one branch. So the what whoever the person taking care of that app will be not available all the time. If anything happens in the odd times, so he or she cannot fix the issue. So there comes a regional manager who visits like every restaurant in that restaurant chain uh, very frequently. And if the oven is broken, for example, then it replaces immediately, automatically. And for example, if we consider a Friday rush, like we'll get like more orders to that restaurant. So one oven is not sufficient, right? So if anything happens to that one container, so there's a panic moment. The restaurant reputation will go down, all the mess will happen. So that manager is Kubernetes, who takes care of the whole chain. Like whenever any issue comes up, he or she, the manager, reacts immediately with the automatic and uh, increases the pods or containers, like increases the oven, so that the orders continues and even the delivery continues. And here, so I came up with this part, auto healing and auto scaling. So what is auto healing? It is like a built-in zero configuration, just replaces the failed pods instantly. So it basically called as reliable feature. So it is reliable on the replica sets. So whenever we configure replica sets equal to 2, that means like two pods should be running all the time. So whenever the system detects like one pod is failed, then the auto healing replaces immediately one more pod. Make sure like two pods are running all the time. It's a desired count. We also call as desired count. So it maintains the desired count. And I'm gonna explain the part in demo, like deleting a pod, and we will watch it like how it returns automatically. And the auto scaling. I'm sorry. Is anyone asking question or?
I think
Okay.
someone is muted, unmuted.
Yeah. Never mind. So the second part too is auto scaling. What is auto scaling? Like it's completely depends on the CPU metrics. Whatever the CPU usage of the app or the system, it reads continuously the CPU usage across all the pods. And whenever the load, we predefine CPU at the usage threshold level. For example, if it is like 50%, and whenever the CPU usage goes down and the threshold level goes up, and whenever it crosses 50%, the traffic is more, and the auto scaling will adds the pods immediately whenever the load spikes. And whenever the traffic is like very low, below the threshold level, it immediately deletes all the unnecessary pods and maintains whatever it required by the system. So I'm going to demo the stress CPU, and I'm going to stress the CPU usage by increasing the load, and we will watch the pods increase. So here it is, auto scaling. And yeah, in auto healing, we have like three important terms like deployment, replica set, and pod. Pod is like very a small unit in Kubernetes, and it runs like one container instance all the time. And replica set is like uh, whatever the replica set number we give, like we initiate like two or three or four, those number of pods will be running all the time. And it is replica set ensures, like it is like a enforcer rule enforcer, like it always checks the pods are running continuously and healthy. If anything like detects mismatch or deletion of pods or crash happens, then it immediately triggers a replacement pod, make sure the replica set number is matching. And all these are, we put it under deployment. In deployment, like it's a node, we take it as for example, as a Docker. So in Docker is like one node, and if we define everything in deployment, like the desired state, we just write once and it will be forever until we change. So the replica sets will be there. So we target as like two, for example, and two pods will be running all the time, and the replica set will be making sure like the pods are running all the time. Even if one fails, replacement will be done. Next. So yeah, this is done. Yeah. So auto healing, what happens step by step? So in the normal state, I explained like the deployment keeps two pods both running. Replica set checks every few seconds, two needed, two running, all good. If the pod dies, for example, like it's crashed or memory error or deletion, something, no alert, it doesn't give any alerts. So replica set has to take care of the pod status.
Pradeep,
And
just one sec. Someone, please be on mute because we are not able to hear you.
Bani
Bani,
Chukku, can you please mute?
Please be on mute.
Yeah, I muted him. Okay, I think you can continue
yeah,
now.
Thank you,
Okay,
Anuradha.
thank you, Anuradha. Yep. Okay, so yeah, second step, the pod dies, whatever the reason, the replica set will check the status of the pods and it replaces immediately. Like if it is one running, then it makes the replica set match all the time, and everything is healed as I explained. So this I'm gonna explain in the demo session, like this I'm gonna use the YAML file, and I'm gonna explain this slide at that time. So yeah, this is the auto healing steps I'm gonna follow. Let me. So I already created a folder called K8's Autoscaling, and here I'm gonna see what's inside. So it's nothing. Yeah. So I'm gonna create now. Quickly, I'm gonna refer the document. Right. So here there's a command. Touch auto healing deployment YAML. And we see the file appears, and I'm gonna copy the content. So here I have pasted it. So as I mentioned, yeah. So this is the YAML content I have placed, and what it is, what it describes. I'll quickly go around on the high level. Like this is the API version, like APIs apps /v1. That's the safest name we can use. And kind is a Kubernetes type is deployment. And here we are naming it as demo auto healing. That's a unique name we should use for the YAML file and for the deployment. And here the specs we are mentioning as replicas. This is an important line, which denotes like the entire policy. The one line, always two copies, like all the time, like two replicas should be maintained to make auto healing work. And this selector, the name itself is self-explanatory, like match labels. Whatever the label we mention here, it should match so that whenever we trigger um, inside the system, like in the backend, whenever any pods deleted or crashed, it takes the matching labels and then auto heals according to the whatever the label we provide here. The name tag. The replica set counts only pods with this label, must match in both places. And here in the speculation container, we just provided as Nginx. So Nginx is the software inside the pod we are using right now. It's a web server, our demo application. And main thing, most importantly, we should be mindful like spaces. Like only we should use the spaces in the YAML file, not the tabs, because one tab key equal to like kubectl apply fails silently, and yeah, that's a messy part. And so I'm gonna use these commands as it mentioned in the lab. So here I already pasted the YAML file and applying the changes. So what it defines here, kubectl is the keyword, like whatever we use for Terraform, like TF, Terraform, like that. Like kubectl is for the Kubernetes, and it's a command. We ask for apply the changes. -F is like a file, uh, whatever the auto healing deployment YAML will be saved. So it's configured. Let's see how many pods are running right now. Like I've already given like 2 replica sets equal to 2. So 2 pods are already created. And now I'm gonna simulate the auto healing concept, like by deleting one of the pod. Delete the pod, and here we should name the pod name. So it's already showing up, the first one, as I thought to take the first one, which is the Unicode QK228. So I'm selecting the pod one, deleting it, and it's processing. All right. Now let's again see the pods. Yeah, you can notice here, the first one just replaced with, oh, I'm sorry. No, yeah, it added here in the down, TPKD8, just 16 seconds before. So this is the auto healing process. Whenever it gets deleted, like immediately within seconds, it creates the another pod, makes sure the replica sets are matched every time automatically. Now, yeah, now the new concept, another concept comes up, like auto scaling. As we already used in the AWS, the auto load balancer and auto scaling, like, yeah, we have already tried with one of the projects by deleting the virtual machines intentionally, and the auto scaling concepts, like it scale up immediately by matching the minimum and maximum desired count, whatever we have provided earlier, like that same concept, like auto scaling, also same in Kubernetes. So here, mainly auto scaling works on the metric server. So what is a metric server? It's a clusters monitoring system. And whatever the machines or the system CPU usage and the memory from every pod, it continuously monitors and uh, track the usage and and it will act accordingly. Like if the threshold level, as I explained, threshold level is below 50%, the CPU usage is like 10%, then the traffic is high and it automatically scales up with increasing the pods according to the traffic spike. And yeah, and one more important thing, like when without this metric server, the HPA cannot be implemented or executed. Like it is like a blind phase. No metric server, then no HPA. So HPA should work based on the metric server, and always it should show like one by one ready. I'm sorry, this not fitted into this box. I'll make sure like this changes afterwards. So I'm going to explain now the horizontal pod autoscaler, what it does. It always watches the CPU, monitors tracks. So whenever it crosses the threshold level, as I explained, it adds or removes pods. No human needed intervention. So only the machine will automatically increase the pods according to the traffic spike. For example, I have taken the concert ticket story. In a normal day, we have like 2 pods handling bookings at certain time, like major consent is announced, and like many like humongous people, like 50,000 people hit site at once. The CPU percentage usage will go like 10%, 95% in seconds, 10 to 95% in seconds, right? It spikes. So the HPA, we already have threshold given like 50%. So the CPU usage is 95%. Then it automatically add pods without like waiting for any command or any execution um, whatever it is, like, yeah. So pod 3, pod 4, pod 5, like from 2 it will increase like until the system reaches like a normal state and normal usage, and everything will be normal afterwards. So here, once like everything is settled down, the CPU will usage will be normal, and all the rush will be over. Then the HPA removes the extra pods, and it will save money. As I said before, like auto healing is a reliability, auto scaling is an intelligence. So it basically efficient and also automatic. So next, I'm gonna, yeah, here I've just given one example, like why resource requests are non-negotiable, like resources, the CPU, like 100 millicore, and maximum CPU usage is like 200 millicore. Like once CPU scale is 60% usage, like 50% above threshold, the scale up will be triggered automatically. And this is how it does. And sorry, this is how it does with the formula, like current CPU divided by request into 100. Like for example, 60 millicore by 100 millicore equal to 60%, which is above 50%, and it scales up. And when there is no CPU request.cpu, then it will be unknown. Like if you don't give the request properly, it doesn't calculate on the baseline, so it will give unknown value. Yeah, so here another script, which I'm gonna do it practically. So I'm gonna create another YAML file for this HPA deployment. Yep. And I'm just gonna copy the script. Right. Yeah, basically, I also explained here minimum replicas and maximum replicas. Like we desired minimum and maximum as we done in AWS. In one of the example I explained, minimum 2 and maximum 5. And we can also increase this maximum to some number, for example, 10. So based on that, based on the traffic and based on the maximum replicas, the system will, the HPA will auto scale to that extent pods, whichever is necessary for the system by the application. System means the application. So I'm gonna apply the changes now. So it's configured. Okay, so these two are already I have created. These are the two pods I have created for auto healing. These are there. So now Nginx deployment, which is triggered, and it deployed another two pods. So total 4 we can see in the get pod status. So I'm gonna enable the metric server for Minikube right here. Like I think it's still processing. Yeah. So we can lively see here from 0 to 1 status. So now it is ready. Like it's really important for HPA to see the status like one by one. Otherwise, like it will fail. Okay, I'm gonna suspend it. Yeah, so still we can see here. And now I'm gonna add the enable metrics. Okay, we see here the message the metric server add-on is enabled. So now I'm going to verify the metric server is running or not with this command. kubectl get deployment metric server -n kube system. So after this, I'm gonna take one option like imperative. We have already given by the imperative command. Um, for example, this. So this is the command we have. The document provides the auto scale deployment, Nginx deployment, like CPU percentage. Actually, yeah, I want to mention here in the document it was mentioned like this hyphen CPU hyphen percentage. I think in the latest version it got this command line is deprecated, so we can directly use percentage hyphen CPU equal to percentage. Because earlier I found error and the message like it's got deprecated. It already exists. Okay. Let me check. Yeah. So here we can see the Nginx HPA, which is like already present. And I think I've given 70% earlier. So I'm gonna make the changes here. Mm, oh, okay, I think I've created earlier and maybe I'll delete it and create a new one. Okay. Uh, Let me create. I think it won't be a problem again. I think my network is lagging. I'm gonna switch off my camera. All right. So I'm gonna create this file here in this folder, and I'm gonna copy the script again. Here we have already given like 50%. What happens if we give like 30% of usage? Apply -f HP Nginx YAML. So it got configured, and let's deploy uh, see the deployment now. Okay. Yeah, so here we can see the new Nginx HPA got added. Like I have given like 30%. This was like the previous one which I used for the trial demo. So this is the one 30% I've just given in the YAML file, and it got populated here. So now, and these are the basic commands we already have uh, given in the document described. Like we can just see the HPA source type HPA. Okay. Okay. I think this is also a typo. We should use HPA and Nginx HPA. So here it provides the details. So make sure the HPA is missing in the guided lab here, this one. So just make sure you add it after the describe. And it will describe, it will show everything, like what are the details of that HPA, Nginx HPA deployment file. Now, I'll try to delete this. And it's one of the deployment has been deleted. I'll use the step 3, which is optional, but I'm going to use this one, and I'll show you how how the load spikes and the auto scale happens. So I'm gonna take this one of the pod. Yeah, okay. Okay, so this is not the right one. So I'm gonna take the right pod. So here, I'm gonna provide this, and here it simply what it explains is like S greater than /dev/null. So S means like it continuously provides the input or the traffic which this /dev/null will throw the output. It doesn't show up, and it will throw the output. It's like a black hole. So it doesn't show up. The command always runs forever. It never stops. S means, and the /dev/null means like it's a black hole. It doesn't show up to the it doesn't show up to the user. The output throws away all the time. So I'm gonna enter. So every time I insert this command, it increases the traffic. So let's watch it in the tab. We should use another terminal like it. This is like we are using this in shell, so it should be running all the time. And the status, we should use another terminal. I think even though I've given like many commands, it doesn't increase this. It didn't scale up, so the system, the application is still sufficient with whatever the nodes it has right now. Okay, I think it's not increasing. It's, I think, sufficient. Maybe I can change the minimum replicas here, and so we can see the changes here. Minimum ports equal to 5, maximum 10, and we should see increase in the ports, but I'm not sure why it is not increasing here. Yeah, if someone already done with the situation, maybe can help me here.
Hello? Hello?
Yes, Ashai. Yes, I can hear you.
Can you go to the previous screen, the first one?
This one?
No, not that one. The previous tab, sorry, not the previous screen. No. The previous
Here.
tab. The
Okay,
first
okay.
one.
Here. Yeah.
Yeah. Are you executing it? Okay. So it's meant to keep running this command continuously, right? Can you
Continuously,
remove
yes.
can you exit and then run it again? Exit from
Okay.
here and then just type exit.
Yeah.
Exit.
Exit, yes.
All right. So run it again, but remove the and sign once you're there.
Okay. Okay.
Yeah, just remove the and sign and just hit enter. once you're done. I think you put a hash button. No. Just remove the hash button as well. Okay.
Yeah.
/dev/null and just hit enter. Yeah. Just leave it as it is. All right. So you can go to
Okay.
your So just give it some time. You can do kubectl get pods, then -w, so we can watch it as it happens.
Yes, exactly. Yes. Thank you so much, Ashai. So we
All
can
right.
see here the pods are been increasing based on the load. Like I think whenever every time we hit this or 3, 4, 5. Yeah, I think I have given replica sets equal to 5. That's why it increased to it increased to 5 pods here. You see here? 1, 2, 3, 4, 5. Yeah. And it can go up to max 10. And based on this utilization or the CPU utilization, it will scale up accordingly. Yeah, I think this is the end of this lab for auto healing and auto scaling. And I've just concluded with the differences. Just I'm gonna read out quickly. Both are automatic, but they answer completely different questions. Like auto healing is like reliability, and auto healing is intelligence. Auto scaling is intelligence. Auto healing replaces pods whenever it dies, and replica set detects the count mismatch immediately. Any time count drops, replace a burnt out bulb instantly. So yeah, here in whenever the pod count changes based on the load, the HPA reads the metric server every time continuously, and when it notices the threshold level of the CPU, then it opens the extra pods and make sure the application running all the time. And some mistakes that can catch when these are the metric servers not ready, whenever the metric servers are not ready, and also the one by one verification doesn't show up, the HPA doesn't always fails. So whenever it's ready, then only it will create. And also the percentage, when there is no baseline, as I mentioned, it will show up as unknown or error. And also the deployment name mismatch, if it is typo or the space issue, it will give a silent failure, no error, nothing scales. So every time just make sure copy paste the name, never retype, or just make sure if we type. And the tabs in YAML, just use the space bar and make sure doesn't use the tab from the keyboard. And yeah, these are the key takeaways. Just quickly, you can just go through around. It's built in, no setup needed. Healing keeps the count, HPA changes the count. Metric server is mandatory for HPA, and one word is everything is automatic, reliable, and smart. That's it from my side, and thank you.
You did all this thing in your local machine, right?
Yes, Bhupendra. Yeah, I've done the first time it worked. I was doing lab 1, lab 2 continuously. It worked. Something is hooking up with that and symbol. I don't know. First time it worked, I guess. I need to check again what it actually does. But I saw somewhere to use that to increase the load. So
See,
I'll
the
make
things
sure
are
that.
you are using Mac, okay?
Yeah.
So, and you are installing, I guess, some tools you are installing in that, and you are using your Kubernetes. But when you are going to the AWS account and you are using the virtual machine, then setup was a bit different, okay?
Okay.
So just try to do that thing also.
Okay. Sure. Yeah. Thanks for the input, sir.
Yeah, because the things are like you are going to work on Ubuntu machine in the enterprise, right? And using Mac, if you are using Mac, but again, you have to work on the cloud. So you have to configure everything in the Ubuntu machine because you are here, you are using Docker desktop and all. But
Yeah.
there we need to install the tools like whatever tools we are having in our DevOps. So and we have to work on the cloud. So things are a bit different, right? Like
Okay.
you did whatever you did here, that is all good. But the things are a bit different there, and you will face the
Yeah.
challenges. Okay, so
Exactly.
yeah, so you have to do in that thing because many people they are not using Mac, so they won't be able to understand. But if they will follow the same thing, they won't be able to complete the things. That's why I'm saying.
Sure. Definitely. Yeah. Thanks for the input.
Anybody has any questions? Or no questions? Anyone?
Any questions, guys?
Yeah, Benjamin. Yeah.
So
Yeah.
yeah, Benjamin.
Yeah, hello, can I be heard?
I'm sorry.
Can I be heard? Am I audible?
Yes. You're audible. Yeah.
Yeah, so like I wanted to ask because you see, this Docker I have your opening right now. Most of the times when you end up running things in your local file and then you tend to upload them on the Ubuntu machine, it tends to have some challenges. So I'd wished probably if you would have done that for us, but you don't worry. Like Bupenda said, I'll also try and then I'll put that because I've done so many stuff on the local machine, but running them on the Ubuntu machine takes a lot of time. Thank you for your presentation.
Yeah, thanks for the input. Even I remember like some time ago, Bhupinder sir was saying like, yeah, the pods will be like keep on failing, and also I've read some sources like always keep failing. There might be like a number of reasons, but yeah, this might be one thing I should make sure because I'm using Mac. But definitely, yeah, thanks for the input.
Yeah, because so many things are there. Like if you are configuring the pod and also so many things works in the backend. Like readiness probe is there. Readiness probe is something the pod is getting fail and it is not able to self heal. Okay, so that is a feature of Kubernetes, but sometimes it is not coming up. So we have to get in that and we have to delete the entire, not the entire deployments. Deployment have their own parts like for the micro services app. So we need to delete some specific deployment. Then again, we have to create. Again, we have to run the entire deployment. So whatever is deployed, it will skip, and whatever is pending, it will deploy that thing. And like that, we have to do that. And in our local Cs, things are limited, so we can't face that thing. So that is the. But overall, it is very good.
Yeah. Thank you so much.
Yeah, the UI is also different there, like the console and all. And then once you log, so which is good. This was good. What you showed was good. But now we are moving forward to production, right? Like this project that we are going to get, we'll be working on that. So
yeah,
good job.
Yep. Thank you, ma'am. Yeah. Shall I stop sharing or?
Yeah, I
Yeah, you
think
can stop sharing.
anybody else has got any other question? If not, then we can go on to the next demo maybe.
But share your files, okay? Share your files in the group.
Yeah, definitely. I'll just make some small changes and I'll share the document.
Yeah, share your files so that others can do this.
Yeah, sure. Are you still seeing my screen? I'm not sure.
Yeah, we can still see
Did
your
I?
screen. Yeah.
Okay. Yeah, the same issue. Stop sharing button is missing here, or I
So
don't know.
try and do Alt Tab and see whether you're getting that bar. You know, the bar is always, once you hide it, it goes somewhere. I don't know why it goes. It is very difficult to
Yeah.
find it again. Yeah. Just see if you're able to find it.
Or maybe someone will start sharing,
Well,
and I think
sharing.
it will
Yeah.
override, right? Yeah.
Yeah. Let me see.
All right,
I'll
maybe
I
Pradeep, I will
can
start
do stop.
sharing.
Yeah, I can do
Yes.
stop participant sharing. So maybe I can stop it from here. Let me try. Yeah.
Okay.
Yeah, it is done. Yeah.
Okay.
Done.
Thank you, ma'am. Yeah.
Yeah, welcome.
Yeah, Ashai, please go ahead. Thank you.
All right. Thank you so much, Pradeep. Unfortunately, I'm the one presenting after you. I don't like presenting when Joy has presented yesterday and you are presenting today. You always have those spreadsheets and all those presentation and all those things. I don't have that now, so you guys will bear with me. So good evening, everybody. My name is Tomiwa Ashai. I'm from DMI Group 2, and I'll be presenting the demo session for today. I'll be presenting on readiness and life proofs. So let me share my screen to get started. Please, if you can see my screen, please
Yes, we
type
can
yes
see.
in the chat box. If you can see my screen, type yes in the chat box. All right, so let me go straight to what we have today. So first of all, okay, so I'll be working on guided lab 05 and 06 that talks about Kubernetes health probes. And we'll be looking at two health probes in this case. We'll be looking at the readiness probe and the liveness probe. So beginning with this, let's start with the scope. So for this guided lab 05, we'll be talking of only readiness probes. And then we'll be taking all our deployments. It will be happening in the default namespace. There will be no services to be exposed yet. And then we'll also prove why readiness matters by watching how it gets rollouts and availability. So basically, these are some of the things we'll be doing when we are working on this particular task. And then beginning with the introduction, in the previous guided lab, just like what Pradeep has shared, we tried to simulate horizontal pod autoscaling, where we defined the number of replicas as 2, and then the rolling update strategy. We have our strategy as rolling updates, and then we set a request and limit so that each pod that gets specified on each node actually gets a reasonable amount of CPU usage, and then it can also extend beyond that to a particular limit. So that is what this is trying to explain to us here. Let me try and zoom in my screen so I can just do a bit of explanation. I don't know if so for this part here, when Sir Pravin had two pods running and then he ran this command, the CPU hits a maximum of 100%, and then it triggered two other pods being deployed. And that is what was happening in this case here, where we have a new container being created and it started running, and another container being created and that started running as well. But now, here is the big gap. How does Kubernetes know when your container is actually ready to serve traffic? So what this thing is trying to tell us here is that the fact that a pod is ready does not mean, the fact that a pod is running does not mean the pod is ready. So just like what was said here, running is not the same thing as ready. So if I was to liken this, I can say maybe I'm asleep and then somebody wakes me up and says, I want you to run 20 kilometers now. Am I awake? Am I awake? Yes, I'm awake, but am I ready to go 20 kilometers? I'm not ready. So it's just like saying maybe I'm going to my office too. Maybe I have an office to go to, and then you just wake me up and say, go to office. Am I awake? Yes, but I've not, I've not prepared myself. I've not taken my bath or brushed my teeth. So running is not the same thing as being ready. So let's imagine this scenario now, bringing it down to DevOps perspective. They said, imagine this. We have a container process that starts, but Nginx is still booting. In that container, Nginx is booting, is passing configuration, is warming the cache, and is waiting on a dependency. So if Kubernetes assumes that the pod is running, meaning that if he assumes that the pod is ready to go, then users may actually hit some timeout or errors because all of this here is still happening. So we need a way to say, don't send me to work until I'm truly ready. Don't allow me to go to office until I've prepared myself. All right. So looking at this, the readiness probe determines if a container is ready to accept traffic. So it's not just that a container is running, but is that container actually ready to accept traffic? Then the other thing is, these other ones, we'll look at them, but let me just read them out. Liveness probe checks if a container is still running correctly. If it fails, the container is restarted. So it's different from being ready. It's like saying, when I now get to office, am I working? Am I doing the work I'm meant to do? Or I'm stuck somewhere? So liveness probe means, am I alive? Am I doing what I'm meant to do? Even after I've been ready? Then startup probe, this one verifies that the application within a container has started successfully. So we don't just leave it that, okay, this is already running. We have to also check if the application within that container has actually started successfully. So now, moving on, what does readiness probe do? A readiness probe tells Kubernetes exactly when a pod can reliably take requests. So that means if this readiness probe passes, then definitely that pod is ready to take on requests. And then, the cycle continues. So now, until the probe succeeds, then the readiness probe will keep failing. And then during that time, the pod does not count that particular it does not count that particular container available for rollout. That is, that container is not ready to receive traffic. And then we will exclude it from endpoints if we're actually exposing a service, if we're actually exposing it as a service. Now, when the probe passes, then Kubernetes treats it as available. So now, in rolling updates, this prevents the platform from swapping out old healthy pods for new pods that are still warming up. So I took some time to actually kind of like explain or understand what rolling update does behind the background. So I'm going to try to just digress a little bit to actually give a good understanding of what this statement is, because we're going to use it a lot in this particular guided lab. So, but before I go on to show that example, look at this readiness probe here. We are saying the kind of readiness probe we want is the HTTP GET. And what this essentially does is it checks this particular path, this path that starts with / on this particular port, right? And it checks it every 10 seconds. But before it starts checking every 10 seconds, it waits for 5 seconds after the container has started. So let me take that again. Readiness probe. What the kind of readiness probe we are deploying at this time is called HTTP GET, and it checks this particular part on port 80 on over a period of every 10 seconds. But before it starts checking, it has an initial delay second. That is, before it starts checking, there will be a 5-second window, right? So moving on, I want us to really understand what this statement means. Let me see. I tried to do something about rolling updates here. Let me try to explain that. So when we hear the word rolling means it's something that is in motion. An update means something that is new. So now if we look at what we have here, let's say we have these 4 containers that are running and we want to perform a rolling update. If we come back to the deployment that was done yesterday, there is a particular key that kind of specifies what rolling update is really about, and they call it maximum surge. Let me see if my page is loading. I'm trying to get to guided lab 03. Okay. Okay, we're here. So now, in the previous demo that was done yesterday, there was something that they mentioned here. Yeah, this particular keyword, maximum surge. It allows one extra pod during update. So if you take a look at what I have here, these are the previously running containers that run Nginx version 1.20.1. And then let's say we have a new version that we want to deploy 1.20.2. Maximum surge, the point of this is to allow this extra pod during this update period, this extra pod here to actually start running. So we have like a maximum of 5 pods. Now, when we want to perform this rolling update, what happens behind the scenes is when we have this new pod being deployed here, and then we have here that the maximum unavailable should be 0. It means we have no downtime. Now, if we look at this first pod that this new first pod that we're trying to deploy, once it comes into this particular node and is ready, once it becomes ready, once it has fully initialized, the containers have been created and the pod is ready, then this particular one will be taken down. This particular one here will be taken down. And once it takes it down, what happens is, let me try and simulate this well. What happens is we now have 4 pods running again. So a new container will be created again, meaning we have 5 versions again running in our environment. And for those 5 versions, we have 3 of the old one and 2 of the new one. Now, once this one is initialized and is running effectively, then this other one again will be taken off, right? And then this one again will be created again, right? So on and on like that till we eventually have the new version running in our environment. So what this essentially is trying to tell us, in this our guided lab 05, is trying to tell us that in rolling updates, this prevents the platform from swapping out old healthy pods. So which means if this does not initialize, all of this will not get taken off, right? So it will not swap it for the new pods that are still warming up. So basically, this one has to essentially run and warm up and be ready before these old ones get taken off. So that's what that statement is essentially trying to tell us here. So moving on, if we want to, let's start this whole process step by step. So I believe this little explanation will really do justice to the other steps that will be running in this demo. So we'll keep files tidy in a dedicated folder, working in the default namespace. So we have to make this directory and then create this particular directory. So let me launch my Ubuntu. I think I'm going to use both Ubuntu and VS Code. So let me ls. I believe I've done some cd into KHS Labs. So let me check. All right, so these are the guided labs for the first 4 sessions. So for the 5th one now, this is what we'll be creating, Health Probes Readiness. That's the name of the directory we'll be creating. So let me just copy this. All right, so let me ls. So the directory has been created. Let me open it in VS Code. I prefer to open this, to copy the required files in VS Code, these required files, so that because of the indentation, and I will show that once we are working now. So on VS Code, let's wait for it to initialize. So once we create this particular folder, then we cd into it, and then we run a baseline deployment that has no probes in it. So that's what we want to do next. So I have to wait for this to finish initializing. Okay, so it has it has initialized. So I'm waiting for my terminal to load up properly. All right. So ls. So this is the folder we'll cd into, health probes readiness. And then we're going to create a file called nginx baseline. We've cd into it here, which is this. We've done this step. So the next thing is to create this file 00 nginx deploy baseline.yaml. So I copy this and I come here, I paste it. So this is the file here. It's an empty file for now. Then the next thing is, instead of VI and then pasting this, I've decided to just open it on VS Code where I can see it and then paste it in there. So I think my screen is a bit frozen. Okay. Let me copy it again. So I'm going to explain what this command, this deployment does, because there is also another thing I want to explain that I find very, very useful, because we will need it. We'll use it a lot in this particular guided labs, and I want us to quickly understand it before we move on. So now the API version is app/v1. What this essentially means is different Kubernetes objects have different kinds of API versions. For pods, if we see for pods is mostly v1. If you look at it, v1. For different Kubernetes objects, we have different API version. So this kind is like asking us, what kind of Kubernetes object are you deploying? Is it a replica set? Is it a pod? Is it a service? Is it deployments? You know, different kind of Kubernetes objects are actually available. So now, in this our own case, the kind of Kubernetes objects we are deploying is deployment. And now this metadata is trying to tell us that what are the details about this deployment, this Kubernetes object? What are the details about it that you can tell us? The first thing is the name of this deployment, this Kubernetes object deployment, is known as nginx deployment. And then the label is like saying, if we're in AWS now, we're trying to create an EC2 instance and we want to tag it. So we are tagging this, we are labeling this nginx deployment as app to nginx, right? And now the next thing is the specification. The specification for this deployment, it means that this deployment, we want it to have 2 replicas, and we want it to have a selector that has a match label selector that matches app to nginx. The reason why we're having this match label here is that by the time we create a pod, that pod will also have a label. And that label, in this case, is app to nginx. And this essentially means that this pod is being managed by these deployments. So I tried to also simulate that to show us what that actually means when we are trying to run Kubernetes commands in our environment. So if we take a look here, let's assume that this is our cluster right here. Our cluster has a lot of labels because a lot of things are running in there. Let's say nginx is running, a database is running with this label, load balancer is running with this label, backend is running with this label. Just like we saw Pradeep, he had auto healing as his own label. So let's say we have auto healing label also working here. So if we are trying to run any kubectl command, and then we are saying, okay, kubectl apply -f, and then for this particular file now, if it's going to apply anything, it's going to first look at the label of this app nginx so that it will know what changes it's making. If we bring it back to this place, it will just be making changes to this particular pod and this particular pod because they are the only ones with the label app nginx. So all these other ones within our environment that are running will not be touched. They will not have any effect on them. So that's why labels are very important when you are trying to work on Kubernetes objects. So apart from that, we already saw what this strategy is, rolling updates. We already know what maximum search means. So for this case now, when we have a replica of 2, the maximum surge means that we only have 3 running when we are performing an update, and there will be no downtime because of this maximum unavailable. Then this template here, this template is essentially saying it's like a pod template. That, okay, for the pod that you'll be creating through this deployment, it will have this particular template. And we already know how a pod template looks like. It's essentially something like this, right? So if we look here, we'll see that it has metadata, it has labels, like this pod here. Pod has it has this metadata, it has labels, it has spec containing all of this, just like we have here. So in this pod now, if we remember in the videos that we watched over the weekend, so Pravin said that the containers, the pods wrap the container. So for this particular template pod, we are saying that the containers for this particular pod is going to have these details. It's going to be an Nginx container. It's going to have this image running on this port. And we already know what this is from Pradip's demo session. So this is essentially what we have when we want to do a baseline deployment that has no probes. So moving on, we can now apply kubectl apply. We are trying to specify the file using this -f. And what is the name of the file? This file, 00 nginx deploy baseline.yaml. So if I come here and I copy this command, I should create my deployments. So, okay, the path does not exist. Okay, that's because I'm not in the right directory. Health probes readiness. So let me run that command again. So the deployment has been created. So the next thing is to check the status of that deployment if it was actually rolled out successfully. So I come here again, I check it, deployment, Nginx deployment successfully rolled out. Nginx deployment is, if we check here, is the name we've given to this pod, is the name we've given to our deployment, Nginx deployment. So now we can do kubectl get pods. Look at this. kubectl get pods -l app to Nginx. This -l means label. What is the label? App Nginx. So it means if we had other applications or other pods running with a different label, they would not show when we run this particular command. So -o wide means we want to get more information about this pod, not just, let me demo that so we'll see what we're trying to say. So if I run kubectl get pods using this label, let's see the kind of results that we get. And then we see 2 of them running, Nginx deployment running. Now, let's see what we get when we run the full command using -o wide. So we can see that we have more information about these pods when we use -o wide. We can see that, okay, this one was scheduled on this my node called dev cluster worker 2. And this other one was scheduled on my node called dev cluster worker. If we check here, we can see the 2 clusters here, right? So we can also describe the pod. We can also describe the deployment that, okay, I want to understand what this deployment is about. And doing that, we can simply run this command, kubectl describe deploy. Deploy is, you can use deployment in this case, it will still work, right? Then the deployment is Nginx deployment. And then I think it's showing here that this is the Nginx deployment. We have 2 desired, 2 updated, 2 total, 2 available, and none is unavailable. 0 is unavailable, right? And then in this case now, one thing I want us to notice that there's nothing about a readiness probe here. There's nothing about a readiness probe in this deployment. That's why we called it baseline deployment in this particular place, baseline deployment. So now, the next thing on our list is, why is this baseline? It mirrors what you have already done because we have no probes yet. So that when we now start using probes, we will understand what it actually essentially does. So now, adding a readiness probe. So now we'll teach Kubernetes when the pod is actually ready. So now we're going to create a new file called nginx deploy readiness.yaml. Our first file was 00. This one is 01. So if I come here, we have 00. So now we're going to create a new a new manifest file. So I can come here, click on enter. Now I have a new manifest file, but it's empty. But we want to demo Readiness Probe at this time. So now inside of this, we're going to paste this, and I'm going to show us where Readiness Probe actually comes in. So we already know what all of this mean. We already know what replicas, match labels. We already know the strategy as the rolling updates. Now, if we look at this, one thing I want to mention first is this. When it comes to Readiness Probe falls under container specification. If you look at everything that we have here, let me give an example. This replica is a child of spec. Selector is a child of spec. Match labels here is a child of the selector, right? So like that, it will be Readiness Probe is a child of this container. So it's a container specific. When we're talking about containers, we are configuring a Readiness Probe for the container. Just like we have a container that has this name, it has this image. So essentially what this is trying to tell us is, for this Readiness Probe, we'll be using HTTP GET Readiness Probe that checks this path on this port, and then it's going to delay first for 2 seconds, initial delay seconds, that is, it's going to wait for 2 seconds. Then over a period of 5 seconds, it's now going to start checking if the pod is actually ready. And then it's going to time out once it pings the pod, and then the pod timeout within 1 second, then it's going to record it as a failure. Then if it records 3 failures, then we have an issue. Then it just needs it to be successful just once. So that is essentially what this Readiness Probe is trying to do at this particular point in time. So going on, we can apply kubectl apply using this file. So let me come here. Let me copy the code again. So deployment is configured. Now let's check the rollout status. So it's still rolling out. It's trying to roll out, it's trying to terminate the previous pods that were running, right? Just like I explained in the previous session, where I was trying to explain what rolling update actually does behind the scenes. So it has rolled out a new deployment. It will terminate the first one, then it will launch the second one, wait for it to be ready. Once it's ready, then it terminates the second one. So that is what has happened here. So we can now do kubectl get pods using this label. -w stands for watch. So we're going to see what has happened in the background. So we just have 2 pods that are running. You will see that they have just been recently deployed. See the age, 44 seconds, is different from this one that we had here before. So it means the rolling updates has actually occurred. So now we can inspect the probe and then look at what has happened behind the scenes. So we're going to run this command. What this command essentially does is more like command substitution. So basically, everything that is going to be run here is going to be put inside this pod, inside this name pod. So when we now want to describe it, instead of running this large command, we're just going to run this particular one. So if I come here and I pick this command, and then I run it, and then I now run this second command, it will be able to give me an information about what is actually happening. All right. So now, if we look at this, one thing I want us to take note is this particular section. So now, are the pods ready to start containers? Yes. Are they initialized? Yes. Are the pods ready? Yes. Are the containers ready? Yes. Are the pods scheduled as well? True. So basically, our readiness probe actually passed. That is what this is essentially trying to tell us. If we look at the previous one we did before, there was nothing about readiness probe here. But in this case, we have configured the readiness probe, and it has actually passed in this particular case. All right. So next thing is What changed? The pod won't be considered ready until the probe passes. With maximum unavailable to be 0, rollouts require a new pod to be ready, just like I described here, that these new ones have to be ready before the old ones get queued. So that is what is essentially happening here. So now we want to break this readiness, right? If you look at this configuration here, what we said is that we want this health check part. We want to check this part on port 80 and see if the readiness probe will pass. But when we are ready to break it, we are now going to change the path from this slash to slash does not exist, right? So how we do that, we're going to copy 01 nginx deploy readiness.yaml, this particular file that works, that has the correct health check path. We're going to copy it, and then we're going to, it's like saying we are duplicating it, right? We're duplicating it. So if I run this command right here, we're going to create another file, which is essentially the same file, but it bears a different name because we want to use it for another different thing entirely. So we call this file nginx readiness broken. So that's the name of the file. And in this case, we are going to VI into it, and then we're going to change this part to slash does not exist. So in this case, I'm just going to copy this and then come here. And then for this particular file, I'm going to paste this does not exist, right? So now we're going to apply this and observe. So we're going to do kubectl apply using this file name 02 readiness broken.yaml. So I'm going to come here and then I'm going to run this command. Let me get the command again. So deployment is configured. The next thing is to check the rollout status. And then for this rollout status, it's going to time out at 60 seconds. So if we don't get any response, then it's going to time out at 60 seconds. That's what is essentially telling us. kubectl rollout status. Which status are we trying to check? Deployment. What's the name of the deployment? Nginx deployment. And the timeout is 60 seconds, and that will be true. So we're waiting for the deployment rollout to finish. So now, if we remember correctly, 1 out of 2 new replicas have been updated. What that is trying to tell us is that we have deployed a new pod, and that pod now has to be ready so that the previous running pods that are stable, they can essentially cancel out, they can essentially be queued or be taken down. Then we'll now pick the second pod as well, and then take the old previously running pod and take that down as well. So the new pods will now be running. But we're waiting for this deployment to be done. So after 60 seconds, we wait for it to time out, and then we see what happens. So after that, after the timeout, the next command we'll be running is kubectl get pods using the label app is nginx. And then from there, we now describe the pod, and then we'll see what happens from there. So now the error timed out, waiting for the condition. So the error has timed out after 60 seconds. So we can now get pods and see what is actually happening. So now, if we see this new pod that is trying to be created is actually running, but is not ready. So it means it must have failed the readiness probe, right? So now I can try to get more information about this particular pod that is running. So I can do kubectl describe pod, and then we put the name of the pod, and then we describe it. So if we come back here, we'll see here that the containers are not ready and the pods are not ready. In the previous one that we deployed, we saw that the containers are ready and the pods are not ready. And if we scroll down here, we'll see it here that the readiness probe actually failed with status code 404. So the readiness probe failed actually in this particular case. So pod conditions should show ready is false, and that is what we're essentially seeing here. Ready is false. And then the next thing is the deployment can struggle to complete a rollout since new pods never become ready. So now we have to fix this readiness by copying 01 nginx readiness.yaml, this particular file, this particular file where we have the correct health check part, and then we copy it, we duplicate it. We duplicate it to 03 Nginx readiness fix.yaml. So we copy this, we come here, paste this, and we have a new file, which is basically having the right health check part in this case. So now we can now apply this particular new file and see what happens. So let me paste this. Let me copy the command and then paste this. And then the deployment has been configured. So the next command is to check the status of the deployment to see if the new updates are actually rolled out, right? Successfully rolled out. Is different from what we are trying to get here, where we had a timeout, right? So next thing is for us to get pods using this label app equals to Nginx. So I can do kubectl get pod -l app to Nginx, app equals Nginx. So we see that we are back on track now. The pods are now ready. They are using the same image that was used before. So the pods are actually ready. We are still using the same Nginx image. So now you saw pods not ready when the probe fails and rollout won't fully complete. Restoring a good probe returns pods to ready and the rollout finishes cleanly. So now the next one is for us to see how readiness gates rolling updates. So this is the real why readiness prevents bad versions from replacing good versions. So now we start from here. kubectl, okay, these commands were what we essentially did before. So if I run this command, I don't think anything would change. This is 03 Nginx readiness fix.yaml. This is it here. So I will run the command again. I feel like nothing should change. Okay, see, deployment.apps, this Nginx deployment is unchanged. Then I can check the rollout status as well. Successfully rolled out, and I can get the pods once again. So we are running live. So the next thing is to trigger an upgrade to a new image. So we're going to do this, we're going to run this command in a declarative fashion. We're going to use this particular image, Nginx 1.21.2. Before I do that, let me check the kubectl describe pod using this pod. So let me know what image is actually running here. So if you look at it here, the image currently running is 1.21.1, right? So if I come here and then I try to, we're essentially running out a new Nginx image. So basically what should happen is that this new image, one container will try to get created. Once the readiness probe passes, then it deletes one of the old previously running containers, and then it performs it in a rolling update fashion. So let me copy this command, and then I come here, and then I paste it. So the image has been updated. So the next thing is kubectl. So I check the status of the deployment to see what is actually happening. So now it's waiting for the deployment to finish. Waiting for the deployment to finish. 1 out of 2 replicas have been updated. If we look at what we've been doing before, by the time we roll out this status, it finishes as quickly as possible. The only time when we had this issue was when we were trying to run this second readiness broken. Does not exist. But in this case now, it's a different, entirely new kind of error that I encountered. So if we try to get, let me try to cancel this. So now let's try to get the replica set. If we see it, kubectl get replica set, we know that when we provision, when we roll out our manifest file using deployments. Essentially, what is being provisioned in the background is a replica set. So now, this is the one we are trying to provision. See the age, 55 seconds, and it is not working. So now, if I do kubectl get pod, I should see that that pod that is not actually being created. So now we can try to check what is going on. We are saying that the status is giving us an image pull backup. That means there's something wrong with the image we are trying to use. So let me try to troubleshoot this. kubectl describe pod using this. So it's using this new image, but unfortunately the readiness probe has failed. The pods are not ready, the containers are not ready. And we are seeing this error, back off, pulling image pull back off. It failed to pull the Nginx image because it could not find it, right? So what we can do is, instead of us using this particular Nginx version, I decided to change it to latest and then run the command once again. And once I run the command, I can check the rollout status and then see what is going to happen at the end of the day. So we see that the rollout is actually happening. We are seeing that the replacement of the old containers are actually working, and then we're bringing in the new containers into our environment. So the deployment has successfully rolled out. And now we can get this replica set again. We should find that we should have the replica set now running. So see it 33 seconds ago. So it is active and it is running. So we can get pods with this label, and then we can see more details about it using that -oy. kubectl get pod -l app equals nginx -o wide. O basically stands for output. So we can see that the two pods are now running. So next up, you see a replica set created, pods become ready, and old pods are scaled down with no downtime. So I think we've done this. Now, we are now saying kubectl set image. We are trying to make the readiness fail again so that pods are not ready. So basically, I'm going to have to run this command again. And then from there, we're going to run this command. I think it was Goodness that was trying to explain what this command does. So basically what this does is, end of file means that it's going to create this particular file, and then it's going to paste this as it is with the right indentations and everything. So I'm going to run this command as well. Click on enter. And then from there, we're going to patch this deployment, but this is not a complete deployment. What this is essentially trying to tell us is this part, I need to change this part. So basically I can pick one of my previous, this is the file that is created, readiness broken patch. If we look at it here, readiness broken patch, the file has been created, but this is not a complete manifest file. So what I can do is, I know this is what we're trying to simulate. This slash does not exist. So what I can do is this, I can come here and pick from this, or from the one that doesn't have, okay, this one doesn't have, it has the readiness broken. So I can come here and then essentially just replace this with this one. Path does not exist, and then we can now run the manifest file. So from there, I can now try to patch the deployment and see what happens from there. So it's trying to patch the deployment patched. So now the next thing is to check the rollout status and see what is going to happen. So as we all know, this is going to check the rollout status of a deployment called Nginx deployment, and it's going to time out after 60 seconds. So after that, we're going to run this kubectl get pods, That is, we want to see if the pods actually got created after we've done this rollout status, right? And the result should be that the rollout should hang or stay in progress because pods never reach ready. All right. So now we are going to try to run this command, kubectl get pods, and then we see what essentially happens. Let's wait for this to time out before we go ahead to run the next command. So just let's recap. Readiness plus maximum unavailable equals to safe rollouts, which means when we say we don't want anyone to be unavailable, then we are making our app actually very secure, such that new pods must prove they are ready before old pods are retired. So in this case now, this new pod did not prove that it's ready. It did not prove that it's ready. So let's check it. We see that this pod is actually the rolling update did not actually perform successfully. So what we can do, we can also describe it. We can describe this pod and see what exactly happened. kubectl describe pod, and then run this. So we can see containers not ready, pods not ready. The readiness probe actually failed with status code 404. So now we can now try to fix it using this kubectl apply -f readiness fixed. That is this number 3, nginx readiness fixed.yaml, which is this one. So we can actually run this, and then that means the reason why we are running this is basically because this is the previously known working version, the stable working version that we know of. If we look at it here, it has the write health check part. It's different from this one that does not exist. It's different from this one that does not exist. So we are trying to essentially perform like a rollback, right? So if we come here and then we run the command, and then we come back here to check the status of the deployment, we see that the rollout should actually work. So in this case, we see that the old replicas are now being terminated for the new replicas to actually come up. So in this case, the new pods actually proved that they are ready. So that is essentially what we need to do in this particular demo. This is the first part. So now this part, I think this one are extra notes, just enough for now. So we can add things like HTTP GET. We can, to a lightweight part, we can add initial delay seconds. We can add timeout seconds. We can add failure thresholds. And then also, when we have rollout with maximum unavailable to be 0, readiness directly enforces 0 downtime behavior. So from here, we can actually now keep it for the next lab, or we delete the old deployment. So I'm choosing to actually delete the old deployment. Before I even delete the old deployment, let me see. kubectl get deploy. Okay, kubectl get pod. So we have this pod running, and we already know if we want to delete this whole entire deployment, we cannot just delete this pod because it will essentially just recreate. So we have to aim for the deployment itself so that it will take down this pod automatically when it's coming down with it. So we can now say kubectl delete deployment. The name of the deployment is nginx deployment, as we've seen so far in our configuration file, nginx deployment. So now kubectl delete deployment, nginx deployment. So it has deleted. So let's get the deployment. We should see that no resources are found, and kubectl get pod. We should see that no pods are also found. So we've taken down our resources. So that's the end of the first demo. So now, readiness answers. Can this pod reliably take requests? Until ready is true, then it will not schedule it to actually take any request, right? So with readiness in place, with readiness in place, Kubernetes excludes not ready pods from availability, and then it protects rolling updates in the fact that it will not replace the old previously stable working version of our application. So now we added a readiness probe, we broke it to see if it's not ready, and then we fixed it, and then we learned some commands, and then the next thing we want to test now is the liveness probe. So that is in the guided lab 06. So I can come here and then work on guided lab 06. I don't know if is anybody still there? I've been presenting. I don't know if anyone is there. Can everybody still hear me? Hey,
Yes, we can hear you.
I've been presenting.
Yes.
Oh, okay. I thought I've been presenting. All right. So now for this guided lab, Kubernetes health probes, we are testing liveness probe in this particular one. We've tested readiness probe to see if the pods are actually ready to receive traffic. The next one is the liveness probe. Now, what happens after our pods have been running for a while? Who makes sure it still stays healthy? Now, that is where liveness probes actually comes in. So the first thing is, now, currently, we've actually built a reliable deployment. I mean, we've implemented a lot of things. We have metric server, like Prandeep just showed us. We've had horizontal pod autoscaler. We have included we've included replicas. We've included rolling updates and readiness probes and all of these. We've done all of this, right? Now, we've taught Kubernetes how to wait patiently before trusting a pod. But once traffic starts flowing, what now happens now? So the hidden problem, what if a running pod hangs, right? Imagine this real world story. Your Nginx pods have been serving traffic smoothly for hours. Then a bug or a memory leak or a network glitch makes one container freeze. And we know that it has already passed the readiness probe, but now it has frozen. But Kubernetes still counts it as being running. So now what we need to do, the process is still running in memory. Kubernetes sees it as healthy because the container did not crash, right? But in reality, it is not responding to requests anymore. So now from Kubernetes point of view, the container process is alive because it has passed the readiness probe. Now everything is fine from a user's point of view. Everything is fine. But now from a user's point of view, half the site is timing out. So basically it means sometimes the application will work, sometimes it doesn't work because this container has been put in a hang state. And once the user refreshes, it might be scheduled on a pod that has actually hanged. So that is what this is essentially trying to tell us. So now you have a pod that is running but broken, and no one restarts it because Kubernetes doesn't know it is sick because it has already passed the readiness probe. So now this is where liveness probe saves you. A liveness probe teaches Kubernetes how to detect and fix stuck containers. So you will tell it, check this endpoint or command regularly. If it stops responding, restart the container automatically. So this is how it works. When it comes to liveness probe, what we essentially want to test is this. We're going to use an HTTP GET liveness probe on this particular part with this particular port, but we have something called initial delay seconds and period seconds. What initial delay seconds means is that once a container starts, before you start pinging it or trying to check if it's healthy, alive, running, whatever you have, wait for 10 seconds. Initially delay for 10 seconds. And then after you delay, you can now start sending traffic after 10 seconds. So you are going to be sending that traffic for a period seconds of 20 seconds. So consequently, you are going to be checking if that pod is actually passing the liveness probe every 20 seconds. All right. So now that's what he's saying here, that here's what Kubernetes does behind the scenes. You wait 10 seconds after startup to let the app initialize. Then every 20 seconds, an HTTP GET request on to this / on port 80. So if it fails several times in a row, the default is 3. That is, if it fails 3 times, then the container will be marked as unhealthy. So then it will restart it, right? So it's a simple but powerful healing loop. So now if we look at liveness versus readiness, if they ask you, okay, what is the difference between liveness and readiness? So liveness probe checks if the app is still alive and responsive. Readiness checks if the app is ready to handle traffic. Just like the example that I made, I'm sleeping and someone just wakes me up. Am I ready to run 20 kilometers? I'm alive, but I'm not ready to run 20 kilometers. I'm not ready to handle that. But for liveness probes, after the app has been running, we keep checking it using these initial delay seconds and period seconds, right? But this one runs before routing traffic. If we see it, when we wanted to perform rolling updates in the guided lab 05, the readiness probe was actually run before routing traffic. If the readiness probe does not pass, then Kubernetes doesn't even schedule the pod at all. So, but this actually, the liveness probes occurs after the readiness probe has passed and then the application is actually running. So think of it like this. Readiness means I'm ready to serve customers. Liveness means I'm still serving customers properly. So now, moving on to the hands-on, I can make a directory and then we call this directory health probes liveness. So I come here, I copy this command. So we have health probe liveness deployed, created. Then the next thing is to cd into it. So cd into health probes liveness. I'm having, okay, let me cd dot dot. This thing is blocking my screen. All right. So cd dot dot, right? So I can now cd into health probes liveness. So now the next thing, this thing is blocking my screen. So the next thing is this. So we can create, we can perform a baseline deployment where we have no probes. I think we did that for guided labs 05 where we didn't have any probes. So I can actually just skip this. And then we go to where we actually need to actually, deploy a liveness probe. So I can create this file right here. Okay, let me clear my screen. So I can create this file right here, nginx nginx deploy liveness.yaml. And then from there, I can now add this particular configuration. So if I come here, I believe we already know what all of this does. I think the main thing here is the liveness probe. So the liveness probes, we are running HTTP get liveness probe on this part on port 80. And then we are saying we want you to initially delay before you start pinging anything, delay for 10 seconds, right? Then period seconds means after this time, you can now start checking every 10 seconds if this application is working well, if it's not hanging. Then the timeout seconds means if you send a ping and you get a timeout, then a timeout within 1 second, then the application is actually hanging. And we are setting a failure threshold that if it fails 3 times, then mark it as unhealthy, right? That is essentially what is happening here. So we can now apply this. And then, okay, let me cd dot dot and then health probes liveness. So now let me run this command again. So the command has successfully run. So we just need to check the status of the deployment and see if it's successfully rolled out. So it's successfully rolled out. So the next thing is to, okay, this one will just show us that we have actually scheduled 2 pods. We are no longer watching if the pods are actually running. So this is done as well. So from there, we can go ahead to inspect one of the pods and see the probe and events that have happened over time. So like I said, this is just command substitution so that I can now run this easily. So now if we look at it, we see that this has already passed. I think this is for the liveness, the readiness probe. Then for the liveness probe, now I want to see if there's anything about the liveness probe here. Let me see. Yes, this is it here. This is it here. We see that the liveness probe is actually working, right? So, and then the containers have actually been pulled and they've been actually created successfully. So there's no issue on that part. So now Kubernetes will periodically verify Nginx if it responds on this, just based on the specification that we've put in here. And then the next thing is sustained failures will restart the container in place. It will restart that container. So now let's recap. Liveness is now active. It won't affect traffic directly because it has already passed the liveness check. But now it impacts process survival, which means that consequently, when we start running, when we start pinging that pod, are you alive? Are you alive? Are you still serving traffic? Have you not hanged? Those kind of things. Process survival, that is what it will impact, right? Now, we are going to intentionally trigger a liveness restart. So now, in this case now, we are going to copy what we have in this Nginx deploy liveness. We are going to essentially duplicate it. But in this case now, we name it this file, and then we're going to replace it with this does not exist. All right, so I go ahead here. I create this file, and then I replace this with / does not exist, right? And then from there, we've done this already, and then we apply. So we see what is going to happen if and when we apply. So I copy this command and I paste it here. And then the deployment has actually configured. So I can run this command here to just watch what is happening. So it's trying to create this container. So that means I'm trying to see what is happening in the background. But I'm meant to actually run this command. I just wanted to quickly let us see what is actually happening when we watch what is happening in the background before anything else. So now, if we see what is happening here, we see that 2 containers have been terminated, right? And then let me check the deployment status. I think it should be done. Come in. I think the deployment should be done as well. Fully rolled out. But we see that the previous pods were terminated and we see what's going to happen. So now, let me show, this is what I'm looking for. Once this runs, and then this is what I'm looking for. So now, even though the deployment was successful, right? Now we are seeing that we are having 1 container restarts. By the time we continue to watch this, we'll see that the container keeps trying to restart and restart and restart, meaning that the readiness probe is pinging. Let me try to see if I can. Can you see? So the readiness probe is can you see here that we have 2 restarts now? The readiness probe is trying to ping this particular pod, but it's saying that the health check part is failing. That means the pod is actually in a hang state. So now it's going to keep trying to restart this particular container over and over and over again until maybe we give it a maximum number of retries and then it eventually just times out. So if you see it here, it's trying to restart it again. It's trying to restart it again. It's still that same container. If you look at it from the very beginning, we created this container 8TLTR and this other container 8WWQMW, and we terminated the previous ones that were running, this KBGMH, which is this one, and then we terminated this one as well. So now this new one that is running is trying to ping it and it's seeing that the liveness probe is actually failing. But we have set it in our configuration that for this particular period, initially delay for 10 seconds, and then you start pinging every 10 seconds. Then once you get a timeout after 1 second, then you record it as a failure, right? So now what is essentially happening is trying to restart that container to see if it's going to actually pick up this container that is in a hanging state. So that is what is happening at this particular point. So now we can see that there's a calculation here. After roughly initial delay, this is our initial delay of 5 seconds, right? Plus this period seconds, 5, times this failure threshold, we will see how the restart works. So that means this 20 seconds is a function of this one, and this one, which is basically the period seconds multiplied by the failure threshold. The result that we get from that, we add it to the initial deployment seconds. So now, if we come back here, we should try to actually fix this probe that is actually failing, this liveness probe that is actually failing. So we have to go back to the previous working version, which is 01 liveness.yaml, but we're going to duplicate it to this particular file, and then we now apply again. So basically, this has crashed, crash loop backup. So if we see an error message that says crash loop backup, basically what that means is that the liveness probe has failed. The liveness probe has failed. So thank you very much, liveness probe. Let's do kubectl get pod. So we see it. It tried to restart 5 times, and none of it was ready. So let's go back to the previously working version. So 01 nginx, and it's going to create a file for us, livenessfix.yaml. And then we can now run kubectl apply-f. What is the name of the file? livenessfix.yaml. 03 nginx livenessfix.yaml. That's the name of the file. So we come here, and then we run it. And then the next thing we need to do, we check the rollout status, and then we get the pods. So kubectl rollout status, and then we are seeing that the deployment has actually successfully rolled out, and then we can get the pods. Essentially, we're actually using only one label. So if we do kubectl get pod, we'll still get the same result. So if we come here, kubectl get pod, we see that is now running. So we fixed the liveness probe, which means in this case, the liveness probe actually passed, right? So now what you observe, the kubelet restarted the container. So if we remember, I think it was Joy yesterday that was trying to explain some of the Kubernetes components that we have. So kubelet now, in this case, it restarted the container after the probe failure. So now once this is fixed, we then restart stop climbing, and the pods actually return to a ready state. So now we've created a failure, watch Kubernetes self-heal, and then we've restarted the container, which is exactly what liveness is for. So that's basically what this demo is about. The other parts now are basically when it comes to the real world, what can the kind of things that can happen, what can the kind of things that we can simulate. So for example, now it says here, liveness is powerful, but aggressive settings can cause restart loops. So now they are trying to give us a guideline here that we can start conservatively. That is, in this case now, if we go and set, if it takes like 20 seconds for our application to be fully ready, and then we set our liveness probe, we set it that the initial delay seconds should be 10 seconds, and then after that, it should start running after 10 seconds. It will fail because it takes 20 seconds for that application to be ready, for that container to be ready. And then we're setting our liveness probe at 10 seconds. All right. So in this case now, we can be conservative. So initial delay seconds, we can set a time range that it should be between 10 to 15 seconds. The period seconds can be 10. The timeout seconds, instead of 1 second, we can increase it to 1 to 2 seconds. The failure threshold, we can increase it from just being 3 to 5. So it avoids killing containers during brief hiccups. So it might just be that something is happening that just the container needs a little bit of more time to actually get running. So let's not try to just kill it in the process. That's basically what that is trying to say. So now it says probe something cheap. Keep the liveness endpoint lightweight. If, for example, if the database is flaky, if we have a funny database, we can prefer the database to fail a readiness probe than a liveness probe, because we know that a readiness probe is just to make sure that the pod is ready to accept traffic, but the liveness probes runs after the deployment has taken place, because if we look at it here, after it's already running, it will be bad for us to delete a pod that is running because it just started throttling. Instead of us to investigate what is happening, the pod eventually just gets deleted. So it's better for it to fail a readiness probe than for it to get terminated after it has started running, especially for a database. We know how sensitive database can actually be. So another thing is, you can separate concerns. You can use readiness to protect users from temporary issues. Since we know that a pod is not going to be ready, we can protect our users in that they will not be able to access the application because it will not be ready. So traffic will still be routed to the stabling version that is serving traffic. So now, if we use liveness, we can use liveness to recover from a deadlock. It might be that, okay, in the pipeline, something is still wrong with our pods. And then running a readiness probe can just trigger the pod to actually come back to life, and then we have sorted out that issue. So now, what restarts? kubectl get pod shows the restart count. I think we simulated that here. kubectl get pods. Yes. So we had 5 restarts in this case. And then we also see here that if it still steadily climbs, either the app is truly broken or your liveness thresholds are too strict. So in this our own case, what we simulated was the app could not actually pass that liveness probe because of what we simulated here. That is going to, this part is not going to work. So the next thing is, we can keep, I think we're already done, but let's see what it does here. It says keep the broken liveness file applied for 1 to 2 minutes and watch. And that is what we have essentially done here, right? And then from there, kubectl get pods and watch, then fix it again with a good file. So I think we've already done that here as well, where we rolled out a new working file. And then the next thing is to check the rollout status of the deployment. And then I think we already did that here as well. So we created a new configuration, and then we checked the rollout status. And then we should see here that the liveness probe actually passed. So let me just check one of the pods that has been running for a while now, and then run kubectl describe pod, then this pod name. You should see that the liveness actually passed, and then everything else, readiness 2 is true. So there is no issue on that aspect. And then troubleshooting. So no restart happens after breaking liveness. After you break a liveness probe, ensure you waited. If no restarts happen after breaking this liveness, ensure you've waited long enough and check the events that have happened, right? So we can run this command. kubectl get pod. Okay, let's see if it works, because I'm not sure if this is gonna work, but okay. So let's see the events that have happened. In this place, the events that happened is successfully assigned this deployment to this cluster 2. So if we check this deployment, that ends with okay, let me do kubectl get deployment. So kubectl get pod. So kubectl get pod. So now if we look at it, it's telling me that I successfully assigned this Nginx deployment to this cluster. I was trying to see if I could find this deployment ending with this file, but it's not there. So now the image actually got successfully pulled. Then the containers were actually created. And then I think can also verify. We run this command. Let me copy the command and paste it. So we can see here the kind of what we actually deployed. The kind is a deployment. It has all of this where we have the strategy, we have the API version, everything we've defined basically in our Kubernetes manifest file. And then what else is important here? Liveness probe, we already set it. Failure threshold, I think we already set that as well. So before that, we can now clean up. So we can keep for future labs, or we can essentially just delete the deployment. So we come here, we run kubectl delete deployment, this particular deployment, and then I think that is all. So if I run kubectl, let me zoom in, kubectl get pod, I should have nothing running, or kubectl get deploy, I should also have nothing running. So that is basically the end of this assignment. Thank you very, very much. So I'm done with the deployments. Does anyone have any question? Thank you, everybody. I see people clapping for me. I was presenting. I did not know anyone was clapping for me in the background. Oh my God. So,
Excellent session.
all right. Thank you so much. Thank you so much.
Anybody has any questions?
I don't think anyone has any question. But
I have a question.
Sandeep, hey, Sabu Pendra. Oh my God.
It's
All right,
very
go ahead,
easy. It's very easy. It's very easy.
Okay. All
See,
right.
when we are writing the code, there is a kind, and you are writing the deployment, right?
Yes.
Can I write replica set there?
Yes, because replica set can use this API version.
So can you tell me what is the difference between replica set and deployment?
I say deployment is like an advanced replica set in such that with deployment, we have this capability of performing rolling updates. We can do liveness probe. We can do many of these things. But when it comes to replica set, we cannot do those. And then I think that's essentially what categorizes replica sets from deployment. It's like an advanced replica set, because essentially if we do kubectl get deployment, we will see that it's still a replica set that is running in the background. So something like that.
No, something else is also there.
Ah.
Okay, do search over it and let me know.
Sorry?
Just search more about this and let me know. Something more is there,
Okay.
because we are not using replica set in the production. We are using the deployment, and deployment have the features like if something is failing, so we can go and we can change the things and we can deploy instantly. So it is not, it is
Okay.
like while running the things, it is correct, we are correcting the things, and it is not it is not taking time. But in the replica set, there are some issues. If we are changing something, then the entire thing will be in impact. So there is some difference. So
Okay.
go and search about it and let me know.
Okay.
Okay.
Okay. Okay, sir. Okay. Any other question?
That's all good. All good. That's all good.
Okay.
Any application deployment we are going to use in this Kubernetes? Any application deployment? Any demo for that?
I don't know if there's going to be any demo for it yet.
All right. All right.
Yes. So I think we're done here.
Great. This is the very important tool in DevOps. this single tool can make you like you can earn in 25 lakh, 30 lakh. This single tool give you that package. So just study this. This is very good tool, Kubernetes.
Yes, because I had to take some time to understand what match labels mean, what essentially is happening in the background when it comes to rolling updates. I just know that it's rolling update, but doing a deeper research, I saw that, okay, what happens in the background is new pods are being brought in, and then the maximum surge now kind of like does justice to what is happening, that, okay, we can have more containers than usual actually running because we want to try and perform an update. So I was able to get some little information about some of these things. And then indentations are very, very important, because when I watched yesterday's demo, I think Joy had the same problem because he had to VI into the file and then paste it. And then for some reason, it was giving some issues because of the indentation. That is why I actually had to use it in VS Code here to actually see what is happening. Like, for example, now this all of this now, you can see that metadata is a child of the template, labels are child of the template, app nginx are child of the labels, and all of those things. So we're able to see it more clearly here rather than just pasting, copying and pasting it here. So if I cut 0, 1, it will be very difficult for me to paste something here. I will not be able to see the indentations more correctly here. So those were just some of the little things that I kind of like noted down. But it's a very interesting topic, and I think I like it because it's written in YAML. You can easily understand what you are seeing. If you look at it, we know that for containers, we have the container name, we have the image that the container will run on. If we go to Docker Hub, we'll probably find this Nginx image, right? And then we know the port is working on. Just is if you spend time with it, you'll be able to understand what is happening. So that is basically it.
Yeah, the thing is, I think you are not aware with the things like there are some extensions for VS Code. So if you will write kubectl and deployment, it will give you the entire code. You have to mention the name of like line number 23 is having nginx. So you have to put that name only and port and all. Otherwise, it will give you the entire code. So there is no need to write the entire code or copy paste. You have to just edit the things. So there are some tools I will share with you.
I think I saw something like that in extension, in one of the extensions. Then we have to configure the extension so that when we create a new file or we are writing a manifest file, it becomes easy for us to write the manifest file easily. I think, is that what you are trying to say, sir?
Yeah, I will share. Actually, I got some virus attack, so my PC got formatted. So I will install it again and I will share with you.
Okay. I crashed my environment too yesterday. My God, it was a terrible experience. So, but yeah, I think that's it. Does anyone have any other question? Thank you, Prandeep. I'm seeing your message here. Thank you so much.
And don't afraid from my questions, Ashai.
I'm just joking. Oh, it's fine.
Great. It was very great presentation. Any other presentation we are having, or we are good to go?
No, tomorrow.
Tomorrow. Okay, great.
Tomorrow. Yes.
And I'm seeing like people are facing issues and they are messaging me, they are texting me. So I think people are not helping them. Just try to help the others also. Okay.
All right, sir. So as many people that try to message me, if I have the time, because my schedule too is very tight, but I try to work on as many as I can get. I hope Patience is not here because she will probably say I'm not helping her. And Lady Faith. All right. Thank you, everybody. I'm very, very grateful to have presented today. Goodness, thank you.
Thank you.
Thank you, Prandeep.
Excellent.
Yes.
Both presentations were very good.
Yes, Prandeep. I don't like presenting before Prandeep because he always has this PDF and he has a lot of presentation slides ready. The people I don't like presenting before Joy. I don't like presenting after Joy, after Prandeep. They usually have these presentation slides and everything. But I think I dedicated, I'm going to do justice. I'm going to compensate for that by drawing diagrams here and there to try and simulate how all these things work. So,
but in the enterprise, you have to prepare everything. So you have to prepare the PDF, you have to prepare the presentation, everything. So
okay.
just
But
go
do we
with
have
that.
to like start it from scratch? Like how they did it? Like we have to explain, okay, what is Kubernetes? What is this? What is that? Or we can just dive down into it like this is what we essentially need to do. Or we have to take it from the very beginning.
Not from the beginning. You're doing what this liveness and readiness probe, right? So related to
Yes.
that, some couple of slides should have been enough. Just saying what you're
Okay.
talking about, and then a little bit about how the file structure is, certain important points inside the file structure. If it is too big, those look at those points only. Like every
Okay.
time how it is, keep on checking every 30 seconds or 20 seconds, all those points, which port number. So maybe those sections, you can highlight in your presentation. And actual live view of
Okay.
demo was very good. You knew what you were talking about, so there was no issues
Okay.
in that. You knew that
Okay.
this is where the, I have to explain, this is how I have to explain. So your explanation was very good. So that's not
Okay.
an issue. Only presentation, if you could have come up with maybe 3-4, pages of slides. If you already have in your mind what it is, you can take help, and then, from just for the content, you can take help, and then you can just, set it up in your, PPT or Google slides, whatever is there, you can do that. So not an
Okay.
issue, but you did a great job.
Okay.
Very nice. Yeah,
All right. Thank you so much.
welcome.
Very good, very good.
Yeah, I would like to add one thing, Ashaya. So I just used Cloud AI for getting the presentation slide. So I just gave 3 to 4 prompts, refined. So I gave like I got 3 presentations, but I didn't like it properly. So I just refined it like 3, 4 times. Then I got the final one.
Okay.
So you can just do that, like
Oh, okay.
nothing like stressed one.
Okay. So just by prompting it, it would actually generate those PPT for me.
Yes.
No wonder when I see your LinkedIn posts, there are always plenty diagrams. I say, wow, how
Yeah.
does this guy have time for
Yeah.
this thing when we are still trying to figure out this?
Yeah.
Use
So
AI
I just
tools.
keep on expanding.
See,
Yeah,
more than
use AI
presentation,
tools.
yeah, more than asking for a PPT, it's more the content which is there, which is going to
Yeah.
go in. That
Yeah.
is more important.
Yeah.
Okay, because
Okay.
sometimes, you don't get good content, even though if you
Exactly.
explain. So you have to go through a couple of iterations and saying, so that you can, put forth your point across whatever you want. Sometimes it may not give you a proper content. So whatever you want, this is what I want, this, be very specific, so that it will give you the correct content, and then you can just paste it in your presentation, or you can ask it to
Okay.
create it and download also, you can do that. But then you're more in
Okay.
control, so you should
All right.
have the it should be in your control. That's what.
No
Okay.
problem. No problem.
Great.
All right.
Yeah,
Thank you so much.
thank you.
Yeah. All right.
I have shared something in chat, like there is an AI for that. That it's a website. You can go here and search. So many AI tools are there. You can search and you can use that tools.
Okay. All right. No problem. Thank you so much.
Upendra, there is an AI for that. What is that? That is the name of the site.
Yeah, you have to search the same thing. There is an AI for that. It will redirect to you. It will give you an AI site, and click on that, and there are so many AI tools. You can search accordingly.
Oh, great. Thank you so
Oh,
much.
okay. Okay.
So
Nice
many
to
are
know.
there. So many tools are.
Very nice. Very nice.
So many, because yesterday when I saw Joy, when she had some issues with running the pods, she used another AI that I've not even seen. I think WeChat or something like that. I see, what is this again?
See,
So,
one
so
more
many.
AI I'm sharing. One more AI I'm sharing. Just search this HOE. It is also having
Okay.
so many AI tools.
Okay.
Yeah, and there's an AI for that. What's the domain for that, sir? I
Just
think
search
you
for
shared earlier also.
dot in. Just search it on. See, let me check.
Okay.
.com. The .com. There is an AI for that .com.
Yes.
Okay.
Thank you.
I'm sharing the link here.
That HO is
Not
not
a,
giving it. The
yeah,
other
yeah,
one
yeah.
I got. Yeah.
Sorry. That is not. Oh my God. It is POE, not HOE. It is POE. My bad. It is
Okay.
POE.
It was showing some hammer and other things.
No. It is POE. Okay, POE.
Okay.
Just search POE. It will also give you AI tools.
Okay.
POE.com.
Right.
So you have to log in. And it is having all like Claude, GPT, Grok, Sora, this, that, everything it is having.
Okay.
And if you want more, then I will give you.
Take one session on that for all the tools.
See, let me share my
Hmm.
screen.
But when I was reading about Kubernetes, it seems as if it's a much more deeper topic than this. We have so many things like daemon sets that schedules one port per node. We have persistent volume claim. We have so many things like that. And then you can taint a node, you can cordon a node. It's unending.
Yeah, there are so many things. Whenever I'm getting anything, I'm just okay. I have to. So many things are there. See, Google Chrome. All right, I will share with you. It is taking time for me because whenever I'm searching, I am just putting it on bookmark, and so many things are there.
Okay.
And now it's more like how we can be faster with all these tools which are available and not do kind of donkey's work, which like creating all the files used to be so much of time it used to take earlier. Now it is like quicker, faster. But we need to know what we want.
That's the
See,
main
if
thing.
if I can share, so many AI tools are there. So many. Like, let me share. I don't know how it is. I'm just sharing the screenshot actually,
Okay.
because the first time, see, whenever I'm searching, so many AI tools I am having. You can see the screenshot like AI, AI/ML courses, AI agent. So many things are there.
Should we stop live
Okay.
streaming or just wondering?
Yeah,
Yes,
we can
yes.
stop. We can stop.
So we'll stop or
No, you have to stop. I think sir is not there. He is busy in some meeting and all. I can also do that, but let me. I can't see the live streaming. You can do that, ma'am. You can do that.
No, it is just going to LinkedIn for me. Sorry, to YouTube. It's just going to YouTube. That's all.
Okay. Okay, then we can meet another day and we can discuss on this.
Yeah. Okay.
All right.
We'll just
No
upload
problem.
that image of yours. Yeah.
No problem. All right. Thank you so
Thank
much.
you so much. Yeah.
All right. Bye-bye.
Thank
Bye.
you for
Good
learning.
night.
Bye.
Bye.
Good night.
Bye. Good night.
Bye-bye.
Someone want to ask something, I think.
No question.
No, we
Just
are all saying bye-bye. Bye-bye.
Bye.
You know, I gave you when you're my haircut.
Leave the meeting, guys. कैसे बंद करता हूँ? We can't end the meeting, right?
We can, and let me exit and then you see whether it ends. There must be some option to end the meeting, right? 1 minute.